At the top of page 531, there's some space. We just went through that chart last class that said what's the different amplitude, what's the different range, what's the different period. What we're leaning towards today is how do we graph, so you can put this as your title at the top of page 531, graphing y equals a sine b x minus c plus d and y equals a cos b x minus c plus d. Now, we can think of A, B, C, and D as transformations. And think back to chapter 3, and we've done this already. A is all your vertical stretches and compressions. B is all your horizontal stretches and compressions. C moves it left and right, and D translates it up and down. And we could work through by taking our normal sine graph or our normal cosine graph, taking key points on those graphs, and applying the transformations in the same way that we did in chapter 3. Unfortunately, with sine and cosine graphs, that gets a little bit tedious, and the points aren't always nice to work with because they're like pi over 3, pi over 6. And so if we think about what we saw in 6.5, we're at 6.6 right now? Yes. So if you think about what we saw in 6.5, that there was a connection between the A value, your vertical stretches, and the amplitude. There's a connection between the B value and your period. There's a connection between your D value and the center line. And if we put all these connections together, we can actually create a different order for graphing sine and cos that makes it easier and shorter. So that's what we're going to do right now. And we're going to title that special order DAB-C. So how does the special order work? Well, the reason we call it DAB-C is that's going to give us an idea for what to do first, what to do second, what to do third, and so on. We're going to start with our D value. And what you're going to do with your D value is you're going to label your center line. Then we'll go to our A value. And since we know that our A value is our amplitude, we're going to use our amplitude and the center line, which we already drew, to mark the maximum and minimum of your sine graph. So you can go, you know that your amplitude is the distance from your center line to a maximum, or your distance from your center line to a minimum. So we'll be able to mark on our y-axis what the maximum and minimum of our sine graph is going to be. Your B value helps you find your period. So remember, so we're going to find the period, and remember that our period is always 2 pi over our B value. And then you're going to take that period and divide it into 4 equal sections. Now at this point I'm going to draw a bunch of dotted lines because that's what the dash means in DAB-C. We are going to temporarily draw the graph without the horizontal translation. That's the dash part in DAB-C. And finally, the C part we're going to apply that horizontal translation. So we're going to do an example at the bottom of page 531. You have some space there. Our example is we're going to graph y equals 4 sine 2 x minus pi over 4 minus 2. Well, let's make it minus 1, so our numbers are all a little bit different. So we're going to go through the process. What does it mean? We wrote down the instructions of this special order of DAB-C and what each of the letters means. What does that look like when we actually have an example to graph that has all 4 of those things? It has a D value, an A value, a B value, C value. How do we go about that? Well, the D value is your center line. So the last value there, the minus 1, is our center line. So the first thing we're going to do when graphing this is go to minus 1, draw your center line with a red pen if you have one, label it at y equals negative 1. That's all you have to do for the D part of DAB-C. The A part. The A part says use your amplitude to find the maximum of this graph and the minimum of this graph. So since the center line is at minus 1 and your amplitude is 4, it's going to go up 4 to positive 3 and down 4 to negative 5. So we use our amplitude and the center line to draw the maximum and the minimum. That's the A part of DAB-C. We use the B value to find the period. So our period in this case is always 2 pi over the B value, and since the B value is 2, it'd be 2 pi over 2, which simplifies to pi. You mark pi somewhere along your x-axis and divide it into 4 equal sections. So cut it in half, then cut each of those parts in half and label those. So half of pi would be pi over 2, half of pi over 2 would be pi over 4, and this will be 1, 2, 3 pi over 4s. We have now done the DAB. Next, we have to, the dash means temporarily draw it without the horizontal translation. So if I'm going to temporarily draw this, I'm drawing a sine graph. Where does a sine graph start? At a maximum, a minimum, or on the center line? Sine graph starts on our center line. So we go to our center line, and at 0, we say we're starting there. And a sine graph starts on our center line going up. So in each of these 4 sections, you're going to alternate. So center line, I have to scroll down just a bit here, center line to maximum, to center line, to minimum, to center line. And we draw this with a dotted line because this is just a temporary graph. This is our graph with all the transformations except for the horizontal translation. So drawing everything so far, you've now completed the dash part, the temporary drawing of your graph. The last thing we need to do is the translation. And we have minus pi over 4 inside of our function. So that would be a horizontal translation, pi over 4 to the right. So we take each of these 5 key points that we've drawn and move them pi over 4 to the right. So this one's on the center line. It's still on the center line, but move pi over 4 to the right. This one is moved pi over 4 to the right. This point is moved pi over 4 to the right. This point is moved pi over 4 to the right. And this point would be moved pi over 4 to the right. Draw it with a solid line now. Because we have finished our graph. So it still is involved, but as opposed to before. So how would you have done this from your transformations unit? In your transformations unit, you would have first done a quick graph of sine x. And you would have had 0, 0 as one point. You would have pi over 2 comma 1, pi comma 0, 3 pi over 2 comma negative 1, and 2 pi comma 0 as your 5 key points. So you're already dealing with those 5 points, and then you would have to multiply y coordinates by 4, x coordinates by half. Then add pi over 4 to x, subtract 1 from y. And there would be a lot of mini calculations you would need to do to figure out all of those points. So this method of DAB-C, as I call it, allows you to do all of that a lot quicker. And just do it in one step. Yes?
When labeling the point, like if I plus pi over 4, how would you label like the last one?
This one right over here, this next mark, if I counted 1 pi over 4, 2, 3, 4, this is going to be 5 pi over 4. Just by the marking that I have. But the fact that we've got a scale already with your maximum and your period label means you don't have to label individual points. Whereas if you were using the old technique of taking these 5 points and doing your transformations, you'd have 5 points to label. Your chances of a mental math error increase. And so this allows us to draw the graph quickly and accurately. So let's look at example 1. First, it says predict all the things, basically asking us to describe all the things. We'll do this very quickly. The 1/4, that's going to be, maybe I'll start the 1/4 down here. The 1/4 is going to be a vertical compression. You're going to multiply your y values by 1/4. The 3, that is a horizontal compression. You would multiply your x values by 1/3. This is a horizontal translation, pi over 6 to the left. And finally, we have a vertical translation, 2 units up. So that would be a description of what would happen, the transformations that would happen to cos x if we graphed it. What we're going to do now, okay, and for right now, we're going to graph it first for at least one period, and then we'll attempt to graph it between -2 pi and 2 pi. Because on an exam, the most typical way that they ask this question is for you to graph it for at least one period. So if we want to sketch this graph, and we're going to sketch this graph using DAB-C, I'm going to start by drawing my axes. I'm going to write DAB-C here just so that I can follow along that I'm doing everything that I need to do. We start with our D value. Our D value is +2. So at 2, I draw a dotted line for my center line. And I have completed the D part. Then we use A, our amplitude, to determine our maximum and our minimum. Our amplitude is really small in this case. It's a quarter. So we have to go up a quarter, which will get up to 2.25, and down a quarter, which will bring us down to 1.75, and that is our maximum and our minimum. So in this graph, it's a really narrow cos graph. We have now completed A. We use our B value to determine our period. And remember that our period is always 2 pi divided by your B value, and since your B value is 3, it'll be 2 pi over 3. So we go along our x-axis and we mark 2 pi over 3 and divide it into 4 equal sections. When dividing 2 pi over 3 into 4 equal sections, it's easiest to find the middle one first. What's half of 2 pi over 3? Pi over 3. Then you can cut pi over 3 in half, and you'll get pi over 6. Then once you know what one section is, you can just count. This is 1 pi over 6, this is 2 pi over 6, this would be 3 pi over 6, and you could reduce that to pi over 2 if you wanted, or you could leave it as 3 pi over 6. We have now completed the B part, so we were able to use the B value to calculate our period, and then we divided our period into 4 equal sections. Next, we temporarily draw it with a dotted line. Now, what kind of graph are we graphing? We're graphing a cos graph. And later on, we'll also deal with negative sine graphs and negative cos graphs. Okay? With a cos graph, you have to ask yourself, does it start at a maximum, does it start on the center line, or does it start on a minimum? Those are your 3 possibilities. And for a cos graph starts at a maximum. So we label our maximum point as our starting point. Then we go through each of the 4 sections and just alternate. So if I'm at a maximum, the next section I'll be on my center line, then at my minimum, back to my center line, and then back to my maximum. And with a dotted line, I can temporarily draw my cosine graph without the translation, the horizontal translation. The last thing that we need to do is to translate this. In this case, it's moved pi over 6 to the left. So over here, I'm going to label negative pi over 6, which is the same distance because my scale's already with pi over 6's. Move that point to the left, move this one 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 to the left. And we have our final graph. So on an exam, they'll ask you most likely to graph at least one period. So everything here is labeled nicely. We've got labels on our y-axis, we have labels on our x-axis, and we've graphed at least one period. Now, the textbook question says, can you graph it from negative 2 pi to 2 pi? So if I was asked to graph something from negative 2 pi to 2 pi, I would still start, I'll just get, I would still start by graphing what we did here. I would graph it with one period using DAB-C, and then after I've graphed it once, then I would say, wow, that's not what I want to do. Then I would say, if I was supposed to graph it between 2 pi and negative 2 pi, what would that look like? Well, some things are going to stay the same. We are still going to have our center line at 2. So I can draw that in all the way across at y equals 2. We're still going to have a maximum value at 2.25, a minimum value at 1.75. And now I have to figure out, when I get to the B part of DAB-C, how do I put my period on here? Well, our period was 2 pi over 3. So if this is 0 and this is 2 pi over 3 is a third of the way of 2 pi. And if I split this perfectly into thirds, I would have 4 pi over 3 there. Similarly here, if I split this into thirds, this would be negative 2 pi over 3 and negative 4 pi over 3. So I need to put this graph that I have here onto this graph and extend it. So what did we do when we had 2 pi over 3? Well, that's where we split this into 4 equal sections. This was pi over 3, this was pi over 6, this was 3 pi over 6, or pi over 2. We split that into 4 equal sections. And then after graphing it temporarily, we shifted it to negative pi over 6 to the left. So what I'm going to do here is I'm going to divide each of these little blue sections into 4. And I'm going to say from the graph above, we know that our graph was starting at a maximum at negative pi over 6. And at each section, it alternated from going here maximum to center line, to minimum, to center line, to maximum. This is the graph that we had above. To extend it to 2 pi and negative 2 pi, we just have to keep alternating between maximum, center line, minimum, center line, maximum, center line. And keep going over here. Center line, minimum, center line, maximum. My shadow is getting in the way. And so you can see why this is a little tedious, why your final exam usually says graph at least one period. How annoying this would be if they said instead of between negative 2 pi and 2 pi, between negative 100 pi and 100 pi. Be going up and down and labeling dots forever. But the idea that once you figure out those 4 sections and mark one whole period, that it would continue at that same pace, skipping from maximum to center line to minimum to center line to maximum to center line to minimum to center line to maximum to center line, and so on and so on and so on. Now, the end of this question says to describe the characteristics or list the characteristics of this function. What that means is basically going through each of these things and saying what they mean. D was our center line, so we would say the center line is at y equals 2. A is our amplitude. We would say our amplitude is 1/4. B is our, helps us find our period, so we would say our period is 2 pi over 3. There's a phase shift of pi over 6 to the left. Other things we could use to describe this, we could say the domain is everything. We could say the range goes from 1.75 to 2.25. So those are some of the characteristics of this graph. Okay, you won't be You won't be asked to list all characteristics in a question. If you're asked to describe things on a quiz, a test, or on the exam, they'll be specific. Can you say what the amplitude is? Can you say what the range is? Can you say what the period is? So it'll be specific like that to help you. Graphing, sine, cos, and tan are very typical questions on the final exam. They're usually worth 4 marks each, so they're a lot of marks. Questions for practice that we're going to do right now are 3, 8, 9, 10, and 11. And I have a note on 11 to remember your special note to factor. Because in this case, do you see you have a horizontal compression and a horizontal translation? But this example that we just did was already in factored form. In fact, the order of doing our things is based on the b value factored out. Sometimes you'll get a question where it's not factored out, so then you have to remember you have to factor first to make it in the right form before you go through and graph it. Okay, so take some time to practice your graphing.